In this lesson, we will cover questions from section 3.8, Factoring Special Polynomials. Question 1. Factor 49x squared, subtract 81y squared. If we think back to all the different types of polynomials that we have covered in this chapter, we know that we have a polynomial of the type trinomial, where we have a greater than 1, less than 1, or equal to 1. But right now we only have a binomial with two terms in between of subtract. And that is a special kind of polynomial, which is called the difference of two squares. Since 49 and 81 are both perfect squares, and they're in between a subtraction, which means a difference of two squares. So when we have that, we can just put our two brackets automatically to make our binomial. And we're going to take the square root of 49. The square root of 49 gives us 7. It gives us 7x, both binomials. And then we have 81. The square root of 81 will give us 9. So we have 9y and 9y. So we have to think back now to the rules of a difference of two squares. Are they both negative, positive, one negative, or one positive? Well, if we notice there is no b term, with no b term, they're going to have to be a negative and a positive that will cancel out the middle term. And you can check that once you multiply everything out or do use distributive property. You'll notice that the middle term is actually going to cancel and be like a zero pair. So our answer here is going to be B. Question 2. Factor 4n squared plus 20n plus 25 completely. Again, let's think back through all the different types of trinomials that we have factored. We have 4, 20, and 25. We cannot take out a greatest common factor. We could out of the 4 and the 20, but we cannot take the same one out through all the terms. But let's think of all of our special polynomials that we can factor. It starts with a perfect square and ends with a perfect square. So once we have this kind of scenario, we can use the perfect square special polynomial. So again, we can put our two brackets there for our product of our binomials. So we take the square root of our 4, which gives us 2n. And we're going to take the square root of our 25. So square root of 25 is going to give us 5. Now, this was a little different compared to our difference of two squares. Difference of two squares has a positive and a negative, or it could be a negative and a positive, because there is no b term. But in this case, we do have a b term. We have 20n. So if we notice there, everything is positive, and we need it to add to give us 20. So if we put this to be a positive and a positive, well, let's check to see if this would work. If we have 2n times 2n, sure, that gives us 4n squared. Let's do a double check there to make sure we're in the right steps. 2n times 5 will give us 10n. Then we're going to move into another other number. 5 times 2n gives us 10n again. And 5 times 5 gives us 25. So we have 4n squared plus 20n. Perfect. That's exactly what we need for our b value. And we have our constant term of 25. Perfect. So I have to keep in mind here, if you're given a perfect square trinomial to factor and every term is separated by an addition sign, both binomials will be positive. If we have a negative here, both binomials will be negative. The only time we will have a positive and a negative binomial is when we have the difference of two squares.